We're going to take a moment now to go down to the Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by. Lori, let's talk about the new study that's on Space Station that's looking at cardiovascular health on the astronauts.
It's called Cardio-Ox for short, and it's looking at the space-related cardiovascular disease risk to long-duration astronauts. Steve Platts is the principal investigator at the Johnson Space Center, and he tells us more about this study.
The short title is Cardio-Ox, and that stands for cardiovascular oxidative stress. And we're looking at how spaceflight may induce oxidative stress and inflammation in astronauts. It's actually something you hear about all the time. So when you see these medications or vitamins, vitamin E, vitamin C, they say they're antioxidants, and you take an antioxidant to fight oxidative stress. So it's a natural process in the body. Every time you burn ATP for your cells to do anything, you produce these free radicals, and your body also produces things that fight them. And you get this balance between the two, and that's when everything is okay. When you get into stressful situations or have other issues, they get out of balance, and that's when it can become a problem.
So they're out of balance, what we see in astronauts, or have we even studied
Our
this yet?
hypothesis is that we're out of balance. There's a little bit of data that shows we could be out of balance in spaceflight, but on Earth, we know that a lot of the situations that they end up in space, the deconditioning, the diet they have, the radiation exposure, all of those things cause oxidative stress here on Earth. So our hypothesis is that it's doing the same thing in spaceflight.
So how are we going to prove this is true?
Well, we have 12 astronauts that we're going to study, and we're taking blood samples and urine samples, and at the same time we're looking at how the blood vessels respond. So we're getting a measure of structure and function, and we can compare the biomarkers that we're getting that show us what degree of inflammation and oxidative stress we have and what the functional consequence of that is.
What do we hope to gain from this?
It'll be helpful for the crew, but it's also potentially helpful here on Earth. So there are all these different hypotheses about oxidative stress and inflammation and how they can lead to coronary artery disease. And that's one of our major research gaps here at NASA is, does spaceflight induce any kind of cardiovascular issues long term, not just while the crew are in flight, but when they return, are we putting them at additional risk for a heart attack or something else? And this study will help us to see if we have any potential preclinical issues. And in the time frames that we're talking about, we wouldn't be able to see full-blown clinical issues. But the measures that we're using can predict future potential for atherosclerosis.
3 astronauts are actively participating in pre-flight and training activities for this experiment. 1 astronaut has actually completed some in-flight data collection, and 3 more have just signed on to participate in the study. We'll see the first post-flight data collection sessions sometime next spring. Now let's take a live look into the Payload Operations Integration Center. And Josh, as you mentioned, they are participating in that simulation. I actually walked in to find out what was going on this morning, and they told me now's not a good time. So I just turned around and left. You know, they have to be prepared. They say sometimes they have to train together for a bad day that they hope never happens, and today is that day. But it's just training, and it's well worth it to be prepared. And you can also see they're waiting for Santa Claus too, those hats and stockings. So hopefully somebody will put something in there. That'll do it for us at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.